Okay, for the last part of chapter 4, we're going to look at quadratic functions. Now, we know what a quadratic equation is. So a quadratic function is just going to be any equation of the form y equals ax squared plus bx plus c. So essentially, it's a quadratic equation we've seen with our a, b, and c, but it's equal to y instead of equal to 0. So since it's got two variables, like y equals mx plus b and other things, this will make a graph. There are other forms of quadratic functions, as we will see. We'll look at vertex form, we'll look at intercept form, and we'll look how those are interchangeable as we move on with this. Now, the big thing is the graph of every quadratic function looks the same. All quadratic functions will simply look like what are called parabolas. And hopefully you've heard that term before. But a parabola essentially is like a U. So it's going to look something like this or something like this. And eventually we can move past quadratic functions to some different quadratic relations. And we'll do some that go this way and we'll do some that go this way. They can also tilt at a diagonal, but that's a little beyond the scope of our class. So for today, just as an introduction assignment, I want to show you the parts of a parabola, the parts of a quadratic graph, and so you could recognize them. And then next week and beyond, we'll start to learn how to do these algebraically, see our different forms. So here's a graph that I make of a parabola. Not a great parabola, but some kind of parabola graph that I labeled some points. You can kind of see I've labeled this point, this point, this point, and this point. Now, some of these should be pretty evident, such as x and y-intercept. Remember, y-intercept, just like a line, a y-intercept is where it intersects the y-axis. This is y, this is x. So the point where it intersects the y-axis is simply 0, -8. Now, the x-intercept, there are actually two, because you can see it intersects the x-axis in two spots. So the x-intercepts are -4, 0, -2, 0. Now, vertex is going to be where the parabola kind of turns, where it kind of changes direction. In this case, it's up here. And I believe I made that at -3, 5. All these are ordered pairs. Now, the new one is called the axis of symmetry. So obviously a parabola is very symmetric. And if I put this line right down the middle, this line would split it in half. So this vertical line is going to split our graph in half. Now that vertical lines are always x equals some number. And since it goes to the point -3, 5, I'll say x equal -3. Has to be an equation, x equal to some number. And it's always this same number that ends up in our vertex. Now, a lot of times we'll talk about, does this open up or down? So does the parabola open up or does it open down? Well, obviously, since it's pointing down, it opens down. And when we say max or min, it's essentially saying, is the vertex, at the vertex, does it take a maximum value or a minimum value? Is it at the very top of the hill or is it at the bottom of the hill? In this case, it is a max value. Other cases, it might be a min value. So for this first assignment, again, we're just going to be looking at some of these graphs and trying to pick out some of these properties. And then on Monday, we'll really start focusing on trying to find these algebraically if we have some equation. So example, if I give you y equals 3x squared minus 2x plus 1, can you tell me the y-intercept? Can you tell me the vertex? Can you tell me the x-intercept? Can you tell me the axis of symmetry? And that's what we'll work on as we finish out chapter 4. So complete these couple problems, and if you have questions, obviously, please let me know.